Assalamu alaikum wa rahmatullah. Welcome everyone to IE 203 Introduction to Industrial Engineering. Today we'll talk about one of the IE areas that we covered in the last session. We said there are 5 areas that we are going to cover during this course. Just in general, we are not going to go in details inside each one of them, since you are going to explore them during your journey in the IE program. Today we'll have the operations engineering area, and in the operations engineering we have many methods and techniques and tools that used to improve to improve the processes or to improve the operations in general. We have, for example, scheduling, like they use them for airline industry, linear programming, which we will also cover today, and it's very common method for optimization. Queuing theory, simulation is very common and known and used in all the fields. Sequencing, networking analysis, stochastic process, decision analysis, that's also very useful tool to evaluate the decisions and select the best decision that fits the criterions you need or your requirements. Inventory control, dynamic programming, all these and others, they are not limited to those. You will explore some of them in separate courses like the simulation. There is a course also, decision analysis, scheduling and sequencing. They also offered in a course, the queuing theory, the same. So you will see them in future courses. Today we'll explore only a few of those, and we will just go over very surface of these techniques to show you what is the area of operations engineering covering and what this area is targeting in terms of using mathematics or mathematical programs or statistics and probability to improve the process and operations based on those techniques. Today we will learn about the linear programming. Linear programming is very common and widely used, and many management decisions involve making the most effective using limited resources. I have only a few labors or a few money to operate my shop. And the objective in my definitely my store is to maximize my profit, or also to minimize my expenses and my cost. Also think about it, you have your allowance, maybe your mukafa, and this is a limited resources to your expenses, how to optimize it and how to use it in the optimal way based on your period or the most important expenses you have. So the linear programming helps in making decision when you have limited resources. Widely used mathematical modeling techniques, planning and decision making related to resources allocation. When we talk about programming here, it's referred to modeling and solving a problem mathematically. So programming is not we are doing coding, even though there are software applications ready to do linear programming and operations research application. But here, when we refer to this method, we refer to the programming that's mean using the mathematical models, المعادلات الرياضية. We are not doing here برمجة, okay? But the word programming comes from the modeling of mathematical problems. Linear programming steps that you have to learn, and or the properties, sorry, before the steps, we will cover the steps in the next slide. We are talking here about the properties and المميزات أو مواصفات linear programming. When you seek to maximize or minimize some quantity, يعني تبغى you want to maximize your profit, you want to minimize your cost, you want to minimize your time of operation. This is an objective of quantity. And restrictions عوائق or constraints محددات أو عوائق are present. يعني عندك عوائق مثلا I have limited resources, I have too much or too many expenses, so I have constraints. One or more constraints, you can have one constraints or more than one. يعني واحد عائق لك للobjective to maximize your profit, or more than one related to that objective. Objective functions and constraints are linear, so they have a relation, and those relation has to be linearly. So you cannot just say this constraints and there is no interaction or relation between that and the objective function. Non-negative, يعني zero or more variables. When we talk about variables, not in terms of the quantity, in terms of the values. Variables اللي هي متغيرات. المتغيرات هذه قيمها it has to be zero or more, it cannot be negative. Certainty, divisibility. Certainty اللي هو الثقة, using these mathematical programs give you the certainty, and also the divisibility, so it gives you also the way or the chance, so you can work in multiple options on results, and you select among them using the steps of the LP. Now those are very important steps to understand them first, and then you implement them, as we will see today when we take the example. 4 steps, and those steps are very basic and easy, but you have to read them carefully and understand them. The first one, actually, it says understand. So you have to understand the managerial problem being faced. So you have to understand your problem. Then you define or identify the objective and constraints. Understanding the problem, this is needed also when you solve the examples and questions in exam here. You have to read and understand the question, because the second step, it will rely on the first one, depend on how you understood the problem. If the problem says maximization or needs to maximize profit, and you understood that's wrong and you do it minimizing, so this is going to lead to a complete wrong answer. Identifying the constraints and محددات to meet your objective, also it has to be identified clearly. Then define the decision variables. المتغيرات, the decision variables, المتغيرات, we have to also define them from understanding the problem. So always we refer to the first one. You have to spend time in reading LP problem, the linear programming problem. You have to read them carefully and take your time to understand the problem. The last step, which is after you finish all these 3, identifying the objective, the constraints, decision variables, then you do the programming, which is the modeling. As we said, you write the mathematical expression for the objective function and constraints. Okay. Before we proceed with the example, there is the numerical solution, and also there is the graphical solution to LP, linear programming. The graphical solution looks like that, but in the graphic, even though the graphical solution very easy to understand or to extract the results and identify the results, but there are some limitation to the graphical solution. Is easy to solve. Small linear programming, not complex one, only works when there are just 2 decision variables. يعني المتغيرات حقتك, it has to be only 2. Okay, not possible to plot the solution for more than 2 variables, and this is one of the lack of the graphical solution. But when you have 2 decision variables, then and you don't have a complex problem, then it will be easier and also easy to extract solutions from here in the graph. Provides valuable insights into how other approach works. Non-negativity constraints mean that we are always working on the first northeast coordinate of the graph. Northeast معناها الشمال الشرقي يعني بالاتجاهات. This is east, north. So we are working this area here. We are working this area. We don't move to this sides here and here because these are negative. So we always work with non-negative constraints, and it gives you a good insights about your work. For example, here you have the constraint 1, constraint 2, and the intersection point between them. So all these considered to be feasible region. معناها all these contains the points where a solution applicable to your objective function can work. Now, one of them compromising one of your objective, constraints, and get the highest value in terms of the others, until you find maybe one point like here in the intersection between the two lines gives you the maximum of both constraints value. But all of these are, they call it feasible, يعني نقاط أو منطقة فيها سماحية لوجود نتائج أو قيم تتوافق مع الأوبجكتيف حق البروبلم حقك. This is how it looks, the graphical representation or solution for the LP. X1 and X2 are the objectives or the constraints you have, for example, or the objective function you have, whether, for example, you want to maximize time, you want to maximize cost, minimize the cost, or maximize the profit. We will see all that in the example, in the next example. This is just to show you here how it looks, representing the constraints and the objective function graphically, and what are the advantage, and we can say the shortcomings or the limitation of using the graphical solution. Moving on to the example, and here we have to pay attention, read carefully the example. We will read it first, and then we will start identifying the major information and how we explore them in reading the LP problem. Furniture company, شركة مفروشات, produce inexpensive tables and chairs. Tables and chairs, طاولات وكراسي, which require carpentry work and painting and varnishing work. الكاربنتري اللي هو عمل النجارة, البينتينج and varnishing اللي هو الفينيشنج اللي هو حق البوية والدهان. Each table takes 4 hours of carpentry and 2 hours of painting. Each table, كل طاولة, takes معناها تحتاج 4 hours 4 ساعات نجارة, 2 hours painting. Each chair, pay attention here, this is chair and this is for the table, okay? And we have 4 hours here, 2 hours here, 2 for painting, for the carpentry. The chair requires 3 hours and 1 hour. 3 hours نجارة, 1 hour دهان. There are 240 hours of what? Carpentry time available, and 1 hours of what? Painting. So I have 1 hour in total, okay, for painting, and 230 hours for carpentry in total. And each table requires this amount of time here, and each chair requires this amount. Now it says each table yields يعني تنتج أو ينتج أو يحقق لنا a profit. يعني each table yields give us or profit, يعطينا profit of $70 and each share profit of $50. البروفيت اللي ينتج من الكرسي 50 ومن الطاولة 70. The company wants to determine the best combination of tables and chair to produce to reach the maximum profit. So they need to know what is the mix combination between chairs and tables in terms of the quantity that to produce in order to achieve the maximum profit. I have the profit of the chair, I have the profit of the table, I have limitation hours for each one, I have the specification time or the needed time for the table and for the chair. Now from here, this is a very a common way to see how the LP problems, they give you information about two variables here. For example, we have in our case, and it's associating with constraints, and those constraints and variables, you would like to at the end have an objective for them, either to maximize or minimize, and in this case they want to maximize the profit as it says here. So maybe it's easier just to pull these data and information in the problem and put them like in a table like this one here, so you can easily look to the information and the data. And then, so remember that the first step, you have to understand the problem as we did here. We read it step by step and take your time in reading this problem, because any misunderstanding of the information here, it will lead to a whole wrong solution at the end. So spending time in this part as much you can, so you can go to the next steps correctly, because the major step, which is the formulating, it's based on the understanding. And if you did the formulating correct, which based on your understanding correct, that means the remaining part is just linear algebra, and it's very simple. You can do it easily. So let's pull this information here in the table. The table divided into the two functions that the furniture company has, the carpentry and the painting. They have two departments, واحد للنجارة وواحد للدهان. And the profit for the company also stated as at the end. Now for the carpentry, the tables, the number of hours that used to do the table for اللي هو النجارة, قسم النجارة, 4 hours, and for the chairs is given as 3 hours. The available work hours or ساعات العمل المتاحة للنجارة, قسم النجارة, is 240. So you put them in this row. You have the available hours for this اللي هو carpentry, and for the painting we have 100 hours available, and also 2 hours given for the table and 1 hour needed for the chair. Now the profit that yield from each one, for the table 70 and given as 50. Now he wants to maximize this profit. He wants to maximize, so he wants to know what is the amount of products or combination of product. How many chairs, how many tables can I produce to maximize my total profit at the end? So our objective is to maximize the profit. Obvious now, and it's clearly stated, you have to maximize your profit. And maximizing the profit is going to be depending on the two variables here. I have them that associating with this profit, which is the tables and the chairs. So those are my decision variables. Those are my decision variables. But my decision variables are applied to constraints, or they are limited to constraints. يعني محدودين بمحددات أو معوقات. What does it mean? And because I cannot just say produce 100 tables and 200 chairs. Why? Because working for each table in each of those departments has limitation. So here is the constraints come from. The constraints come from, for each of my decision variables, come from the limitation I have for the working hours. So if I just say 400 tables that I would like to produce, 400 tables, when you multiply them with the 4, that will exceed the number available hours for the carpentry department, and you cannot produce that amount, even though you are going to increase the number of you will increase your profit, I mean. So the available hours here, I have it as a constraint. How I formulate all these into mathematical formulation, this is the programming step that we stated earlier. So let's see how we do the formulation. The solution says it's a maximizing profit. So this is the objective. When it says ask you, the question by the way, can come in different directions. Can ask you only to formulate objective and constraints, or only identify the decision variable, or to find the final answer by finding a certain point and how much will be the tables and or how much will be the profit at that point when you have this number of tables and chairs. So it can come in different directions. Here it will show you the complete set of answers that fulfill all the requirements that you may face. Now maximizing the profit is the objective function. The constraints اللي هو المحددات, I have them: hours of carpentry time and hours of painting time. In the table here, 240 and 100, those are limitation I have and constraints. The decision variables, as we say, those are the variables associating with my objective function, which are the tables, number of tables, and number of chairs. Maximizing the profits mean that $70 times that decision variable associating with that $70, which is the tables. The $50 is the chairs. So we write the objective function as it's stated here, 70 times t plus 50 times c. Because when I multiply those with the decision variable, I get the objective function value, which is the profit. Now I want to maximize it to the maximum. So how much should I put here and how much should I put there? This is the one answer we want to find using the LP. Developing the mathematical relationship for the two constraints. For carpentry, total time, we have the total time stated in the table for department حق الكاربنتري, 4 hours per table, and times the number of table produced, plus 3 hours for chair times the number of chairs produced. هنا 4 hours of table times the t. لأنه if I decided to let's say produce 2 tables, أنا قررت إني أسوي طاولتين. How many hours I will need for the carpentry department? I will multiply at 2 tables times the 4, لأنه each table needs 4 hours. معناها قسم النجارة يحتاج 8 ساعات لإنتاج 2 tables. واضحة؟ The same for the chairs. I decided to do not 2 chairs, I decided to do 5 chairs. Let's say 10 chairs, 5 for each table. 10 chairs I decided to do, so I will multiply the 10 chairs times 3. So قسم النجارة, they need 3 times 10. That means 30 hours of chairs, 30 hours of working for chairs, okay? So this is how I stated the carpentry department equation. 4 times t, the time needed for the t, which is the 4 hours, plus the 3 hours times the c, which is the chairs. Those has to be equal or less the 240, because you cannot exceed the available hours you have for the carpentry department. قسم النجارة ما يقدر يشتغل أكثر من 240 ساعة في اليوم ولا في الأسبوع ولا whatever is that. So I have 4 times t from the table plus 3 times the chair, because the number of chairs are the decision variables and the number of t is the decision variable also. So I have 2 decision variables, and in this case I can use the graphical solution to show my answer in addition to the numerical one, because I have only 2 decision variables as the rule stated, or the properties of the graphical solution problem here. Sorry, yes. Only work 2 decision variables. So we can also here apply our graphical solution. Now for the painting, we will do the same. The painting department given information is here. For the one table, I need 2 hours of painting. So if I said before 2 tables I would like to do, so I will multiply 2 times 2. That's mean 4 hours I need for the painting department to do the tables. And the 10 chairs, let's say I decided to do, then each chair need 1 hour. That's mean a total of 10 hours for the chairs in the painting department. So 2 times T plus 1 times C, it has to be less or equal 100, because these are the maximum or available hours for working in terms of the painting. So the formulation for the painting will be as given: 2 times T plus 1C less or equal to 100. Now we identify the objective function. The objective function is this one here. We identify the first constraint equation, which is for the carpentry department, and we identify the second constraint equation, which is for the painting department. We put them together here, as you see, and then we have to also specify this. As we said, when we work on the LP, the decision variables has to be non-negative. So both of them has to be greater or equal to 0. And you remember, we are working on the positive value. So always, this is one of the constraints you will have to put. We cannot say that we are going to produce minus table, okay, or minus chair. Okay, so we put T and C greater or equal to 0. All the time we put this constraint in addition to any constraints we formulated. This is one of the fixed constraints you have to put اللي هو for non-negativity values. Okay, so how exactly, if the question asks you just to formulate the objective function and the constraints, you write this in the blue font here. This is the answer for the formulation. You state the objective function, maximize profit. This is the objective function, equal $70 times T plus $50 times C. Subject to معناها إيش؟ خاضعة لهذه المحددات. يعني and this is the reason I cannot put 100 or 300 and just say I'm going to maximize profit. No, they are subject to, يعني خاضعين لقوانين لمحددات. These محددات or constraints are listed, and you list them like this: 4T plus 3C less than or equal 240, and you specify this constraint referring to what? Here, carpentry constraint or carpentry department hours constraints. It's okay, write it as long as you just specify this is related to what. For 2T plus 1C less than or equal 100, this is for the painting constraint. Always this is fixed, so always this is 1 point guarantee. You have to write it. T and C, all the decision variables you have greater or equal to 0, and you stated this is for the non-negativity values or non-negative constraints. This is fixed for all the LP problem. Those depend on your case. This is how you formulate the LP problem. It's very easy, and usually you are dealing with a linear program, linear problem, linear algebra, first equation, first degree equation for unknown. So something that's very simple, you can do it with your calculator. In the operations research course 1 and the advanced operations research, that courses you covered in your journey in the industrial program, you will cover more advanced problem compared to this one, and you also will cover more methods to solve operations research problems. Now, continuing with the graphical solution, we decided to have the X coordinate or the horizontal line for the tables, number of tables, and the C is the Y vertical or the number of chairs. This is depend on you. This is optional which one you choose, but you put the decision variables that associating with the objective function for in the graph, so you can start illustrating or رسم linear programming or your problem graphically. We first identify the set of region or feasible solution. We plot each constraint equation on the graph. So we will plot equation حق constraints those. This one it doesn't need to, because already you are working on the northeast. Remember the northeast, الشمال الشرقي, this area. So this area will be always on plus, no negative. For those two constraints you have to draw them here. عندك معادلة خطية. معادلة خطية mean linear equation here. This is a linear equation. I can draw it easily on the graph, and we will see how in the next slides. You graph the equality of portion of the constraints, and you solve for the axis intercept and draw the line. We will see how we will do all these steps. So for the carpentry constraint, we have the equation 4t plus 3c equal or less 240. You substitute 0 with one of the variable. يعني خلينا نقول we will put t equal 0 to find the c, and also we will put the c equal 0 and find the t. When you find these 2 points, you start drawing them on the horizontal and then مد الخط ما بين النقطتين. So let's start with the first one. 4 times 0 حنحط substitute the one of the decision variable, put it as a 0 so you can find the other one. So we put this as 0, so 3c equal 240. We divided over 3, c equal 80. Where is the c coordinate? Is in the vertical and y-axis. Where is the 80? Here. So you put and draw the point here for the c. Now, what about for the chairs? So instead of the t equals 0, we will put the c equals 0 this time. So we put c equals 0, the chairs is 0. For table equal 240. So we divide it by 4, the table equals 60. So we go on the horizontal line for the table and we draw the point 60. Then you draw a line between the 2 points. تحط خط، ترسم خط مستقيم بالمسطرة between the 2 points, the 60 and the 80. And this is the first constraint equation. It's graphically represented. خلاص احنا عملنا عرض رسمي وبياني لمعادلة الأولى من المحددات. Now we do the same for the second equation. Before we explain this, let's do the second one and then we go back. For the painting constraint equation, we will do the same. The equation says 2t plus 1c equal or less than 100. Now you put it equal 100 because you are dealing with solving this equation. So you have to move values from the side and divide. فتخليها بالequal عشان توجد القيمة. The c equal, we will leave the c and we put the 0 for the table as we did before. The c equal 100. Then in this time we put the c equals 0 and solve it for the t. 2t and this is 0 خلاص gone equal 100. 100 divided by 2 يعطينا كم 50. So the value of t equal 50. We go to the horizontal line and find the 50 and we put the point and we call this point t equal 50 and c equal 0. The same we did for this one. You go for the vertical or the y-axis. The c-axis here we have it called the chair axis, okay? And in this one you put also the point for the 100 and you call this point لها اسم. أي point موجودة في الcoordinates عندنا لها اسم. t equal 0, c equal 100. This is the point z, 100, okay? Now we draw the and the second constraint equation graphically. Now we want to put them together and find how they will look like. We put this constraint and the previous constraint together that we draw from the previous constraint equation. When you put them together, they will look like that. This is for carpentry, اللي هو قسم النجارة, and this is for the painting equation. So the intersection point, you find it somewhere here, and all these area considered to be a solution applicable for your problem and meeting or يعني fulfilling your constraints. أي نقطة هنا حددت هذه النقطة. إيش النقطة هذه؟ 40 و20. 40 chairs and 20 tables. If I go and I apply it to the profit, it will give me a value, and the same time it's under the constraints that or meeting my constraints. يعني ما تتعدى الضوابط حقت the time available for the time of tables and the time for the chairs. So if you go and apply 40 and 20, you will find the values are going to be meeting the constraints. معناها منضبطة. Any value you find it here above the lines. Where is the first line here? We have the first line is this one, the carpentry, okay? لأنه the painting, it's a little more. So this line is getting a larger area. But if I'm exceeding here, let's say I'm going to do 90. The 90 under the painting constraint, but it's above the carpentry constraint. So if I put 90 chairs and whatever tables, I will put, let's say 20 tables, I'm going to avoid one of the constraints. فمعناها a graphical solution give me the ability to look to the area where is the solution applicable and where can I find my solutions easily. Also, if I want to maximize my profit, usually I look in the intersection point because this is the maximum point for both of the decision variables. يعني in this case here in the middle of 50 and let's say 20, maybe 6 or 27, this is where is the maximum I can get, and you can apply it and try and see how much is the profit will be. I will do and show you here an examples. Let's say we are going to take 30 and 20. 30 and 20. It's graphically drawn here. This is 30 and 20. This is 30 and 40, and this is 70 and 40. 70 and 40, it's going to void the carpentry or one of the constraints. I think here is, yes, the carpentry constraint. If you are selecting a point on the line, it's okay. Read these instructions. Those are going to apply for any graphical constraint equation. Any point on, على, or below, تحت, the constraint plot, هذا constraint plot, الخط الأزرق هذا constraint plot, will not violate, will not, شوف انتبه في نفي كثير في الجملة هذه, will not, okay, معناها will not violate معناها ما حيكسر الconstraint or restrictions, حيكون okay. Any point above معناه هنا أعلى من البلوت هذا, الخط الأزرق أعلى منه زي ال 70 وال 40. will violate معناها حيتعارض أو حيكون ضد أو يعني against. هذه synonyms للviolation اللي هو زي لما أنت تتعدى السرعة القانونية, هذه violation للسبيد. فأنت هنا you violate constraint or restriction. طيب, let's say we take 30 and 20. Now in this graph here only one constraint drawing, but in this second one here both of them are drawing. So 30 here for the chairs and 20 for the tables, or it was the opposite. Let's confirm first. Yes, it's 30 for the tables, I believe, and 20 for the chair. No, this is only working for the, sorry, for the one of the constraints. Let's take for the both concept because it's the same. So let's do here 30 for the tables and 20 for the chairs. So 30 for the tables is here. This is the 30 and 20 for the chairs, okay? Oh, okay, the 30 is here, I'm sorry again. 30 is here for the tables and 20 for the chairs. 20 chairs is here and 30 is here. So the point, it has to be, let's say, here. So, يعني, approximately, the point will be in this area, okay? So here we have to calculate and solve the objective function to find the profit, how much it will be at this point. And also the graphical here, if you draw it correctly, you don't need to check that you are avoiding the constraints, because any points here, it will be not violating the constraints. But if you are solving numerically without a graph, then it would be better to apply those points into the objective function to verify that you are getting, you have to verify with the constraints equation to verify whether you are not exceeding the constraints. So if we have taken the 30 for the tables and 20 for the chairs, we apply them to check. This is just to show you a double check if you didn't have the graphical solution, and I'm going to rely on my checkpoint here on the point on my correction. and هذه يعني خطوة ممتازة يكون عندك في اللينير بروجرامينج انك تتأكد من اجاباتك. If you have selected points, you can go on the constraints first and make sure that you are not voiding. You apply a 30-20 to each of the constraint equation. 4 times 30 plus 3 times 20, how much it will equal? 180. Why عندنا check mark is right, correct? لأنها less than the 240. معناها we didn't violate the constraint equation حق الكاربنتري. We apply 30 and 20 for the second constraint equation. The 2 for the tables, and 1 times 20 for the chairs. 2 times 30 for the tables and 1 times 20 for the chairs. And then that will lead us to 80 hours needed to complete this job of 30 tables and 20 chairs in terms of the painting department. And that's also not against our constraint equation for the painting. So both the constraints are not violated in using this quantity of tables and chairs. Then you can calculate the profit by applying in the objective function. Don't forget the objective function that we have found from the beginning here in this slide. The objective function says $70 times the number of tables you are producing plus $50 times the chairs you are producing. So you have to multiply that in the equation here, and you go apply the 30 tables times 70 and the 20 chairs times the 50. That will lead us to the profit. It will be $3,100. So that the profit you will maintain or you will achieve when you are producing 30 tables and 20 chairs. Remember, when we have selected those points, we select them in this here in the feasible region. You can go up to the intersection point, but don't exceed any of the lines of the constraints. If you exceed any of the line of the constraints plot, that means you are going to avoid the constraints. معناها you will violate the constraints. Okay, so either on the intersection point or in any points on the feasible region. You can try all the points and see here which one show you the maximum profit in terms of maybe you are looking for profit just come from the painting or from the carpentry. But if you would like to maximize the top for both of them or in the total of them, always look in the intersection point that you will get the maximum of both constraints. Now we are checking a point where it's violating, just to show you how you are selecting points violating the constraints. Those points selected 70 tables and 40 chairs. 70 tables. We start always with the x-axis in the points, okay? 70 معناها هنا, and 40 chairs. 40 chairs is here. Let me draw the point here. So this is 70 and we said 40. So 40 is here. We are talking about somewhere here in يعني approximate هذه رسم hand. So we are talking about this point. You see how this point is away or above the plot for the constraints. Above here or above there is the same. You are violating it. The distance, it doesn't matter, okay? As long you are crossing the line of the plot, that's mean زي عداد السرعة حق ساهر. If you cross هو بيقول لك مثلا 120 وعندك الان 100 وما اعرف 125 ولا 126 يعني you cross by 1 kilometer per hour more خلاص الفلاش لقطك فيعني تروح تسدد. Okay, طيب 70 40 now you apply it to the table and the chair constraints equation. For the carpentry constraint equation, we apply the 70 for the table, 4 times 70 plus 3 times 40. That lead to 400 hours. The limit we have, a constraint is 240. So we are exceeding. That's why we see cross. No, sorry, we cannot take this amount of quantity. If the Department of Sales قالوا لك زيد المبيعات ولا زيد عدد الكراسي, yes, but the working hours here will not, the operation department will say, no, we cannot work on this amount of tables and chairs because it will exceed the available hours. And painting and constraints equation, we will apply the same coordinates and the value will equal to 180 hours, and that also exceed the 100 hours of painting constraint. Let's take one point that is contradicting with one and works with the other. But if it's working with one and contradicting or violating the other, then it cannot be working. We have to maintain points like this one here, okay? So let's take 50 and 5. Let's see 50 and 5, where do they fall? Where is our figure here? Sorry, yes, 50 is here. And let's put another color. 50 is here and 5. 5 is almost there. Yes. So we are talking about somewhere here in this area. Our point for 50 tables and 5 chairs. You see, it's exceeding one of the plot for the painting, but it's under the carpentry equation, okay? So it's under the carpentry equation. يعني هي تحت حق قسم النجارة is fine, لكن it will be violating الpainting, okay? It will be violating, sorry, it will be violating painting. And in this case, we are going to implement those points again in the equation. So we put 50 chairs times 40 plus 5 times 3. 5 times 3 is 15, and 4 times 50, I think to 200 تقريبا, yes, 200. So 200 plus 15 will be 215, and that is meeting the carpentry constraint. See, 215 is less than 240, yes, but for the painting, now the painting, you will multiply the 2 times 50, 100 plus 1 times 5 is 5, 105. You are exceeding the painting constraints by 5 hours. That's why you cross that one. So we cannot use this. This is not feasible solution. You say this is not feasible solution. This one is not feasible solution. This one is feasible solution. معناها حل متوافق مع الكونسترينتس حقتي والقوانين الوركينج اورز للقسم النجاره والدهان عندي في الديبارتمنتس. So it's feasible. Now I want you to try at home. Try if the profit for 30/20 اللي هي هذه اللي اخترناها أول is 3,100. For the point 25 and 30, how much will be the profit in dollars? And this point are feasible or no? You have to check the feasibility as we did here. And then if it's feasible, like this one here, you go and calculate the profit and compare it with this first feasible point we have, the 3,100 that gave us. If it's feasible, first, you have to check the feasibility. If it's feasible, go and apply it for the feasibility. If it's okay, then calculate the profit and compare it with this point here. This is your home. Try it and work it at your home. This is how the question of linear programming comes and how the linear programming concept works. It gives you the chance, even if you are going to reduce the number, let's say in the tables production, you want to increase the number of chairs or the tables, you can manipulate تتلاعب بأرقام التيبلز والchairs production numbers على ال availability hours you have for each one of them based on the constraints to manage your profit at the end, okay? Based also on many factors, الديماند المطلوب للكراسي والtables and all others, material maybe you have and other يعني factors that may affect your decision at the end. But then the decision for the manager to select the points from the feasible. But if I ask you for the maximum point, you always look in the intersection points here. Software application in operations research, that also you will learn inshallah when you take operations research courses. It will also help you to identify the maximum point in the intersection point where you can find the maximum profit. And you can do the trial here until you get the maximum point that maintain the constraints equation and at the same time give you the maximum profit you could achieve from the production of tables and chairs. I hope you enjoyed this session and you learned from the linear programming. Thank you for watching, and I will see you in next session talking about different methods and tools in the industrial engineering.